This is problem 5 on page 97. dr d theta equals to parentheses r plus e to the negative theta times tangent theta. Well, I don't remember ever doing this one before, and a lot of the problems I'm working in these videos are problems I'm doing for the first time. So we'll see what happens here. But in order to think about it as a first order linear differential equation, I need to rearrange the terms so I can go after the integrating factor. So I'm going to treat r as my dependent variable, like y would be, and theta is my independent variable, my input variable, like x. So thetas are like x's, r's are like y's. So I have dr d theta, and I need to bring the r term to the left side. So I will subtract r times tangent theta minus r tangent theta, and that equals to e to the negative theta tangent theta. So the integrating factor will be e to the negative tangent theta, because negative tangent theta is my p of x and r is my y. So the integrating factor is e to the negative, I'm sorry, we have to integrate that, e to the integral of negative tangent theta d theta. Alright, so what is the integral of tangent theta? And I'm looking up just to make sure I don't screw it up. It's the negative of the natural log of the absolute value of cosine. And with this negative here, this is e to the natural log of the absolute value of the cosine of theta. And then the e and the natural log cancel, so it's simply cosine theta. My integrating factor then is cosine theta. So I need to multiply this whole equation by cosine, and let's see what happens. We have cosine theta dr d theta minus r sine theta, because tangent is sine over cosine, so when I multiply by cosine, the cosine cancels, leaving sine. And over here I've got e to negative theta, same thing, cosine cancels, leaving sine theta. Well, presumably the left side is the differential of the integrating factor times my variable r. So it's a differential of r cosine theta. And that equals to e to the I theta sine theta. Not the differential, I'm sorry, it's the derivative with respect to theta. So the left side is the derivative with respect to theta of the integrating factor times my variable, my function, r. R cosine theta, if you're pretty familiar with polar coordinates, you'll recognize that as simply x. And so I just thought I'd throw that in there. I don't think that's going to help us solve the problem. But if I separate my differentials, then I've got, let me go up here. I've separated the differentials by multiplying through by d theta. So we have the differential of this quantity equals to e to the negative theta sine theta d theta. And at this point, the variables are separated. I can integrate. And the left side is simply r cosine theta. So let me write my cosine a little better. Now I think we've really latched on to the tiger's tail here on the right side. This integral is kind of non-trivial. let me work through it. I'm reasonably confident you've seen one of these before, but let me just take a little break here and work out this integration. And the troubling thing is that we have to use integration by parts twice. So integration by parts, you work with a u dv. So let me just let u be e to the I theta and dv equal to sine theta d theta. So differential of u, du, is equal to minus e to the negative theta d theta. And v, if I integrated this, I would get minus cosine theta. Alright, so this integration by parts will be u times v, which is negative e to the negative theta times cosine theta, so that's u times v, minus integral of v du. Alright, so du is negative e to the negative theta times d theta, and v is negative cosine theta. Well now, we have a couple of negatives here that do cancel, but I'm down to minus e to the negative theta cosine theta minus integral e to the negative theta cosine theta d theta. Alright, and at this point we have to do this process again on this integration. Alright, so this these are doozies to work through, and I'm going to let me separate it here. U equal to e to the minus theta as before, and dv is cosine theta d theta. So the differential u is going to be minus e to the negative theta d theta. And v, if I integrate cosine theta, I get sine theta. V is sine theta. So we have this part, which hasn't changed, negative e to the negative theta cosine theta minus, and now we have integration by parts. So let me just keep the minus outside a bracket, and I just work with this integral. This integral is u times v e to the minus theta sine theta minus integral of v times du, negative e to the negative theta sine theta d theta. Wow. All right. And these two negatives cancel. Okay. Now, this is when I really need a larger board, don't I? The secret to finishing this is kind of tricky. And usually, ironically, usually I use the letter I, but since I is the integrating factor, let me use a different letter. How about we call it J. J. So this integral here is, I'm going to call it J. And guess what? J reappears down here. And so all I have to do is look at J equals to this mesh right here and then solve for J. So I'm going to do some erasing here, and I'm going to lift this part up to here, taking out the minus sign in the bracket. And so I'm going to do some erasing. I'm going to rewrite that, but that's what I'm going to do. I'm going to erase all this stuff. I'm going to take this, lift it up to here, remove the minus sign in the bracket, and then we'll finish the problem. I'm back. So we have our original integration, which I called letter J, equals to this stuff. And what I did was I took the negative sign out, so that became a negative. And this became negative, but this was J. What I'm solving for is the integral I'm solving for. I'll put that in green just to emphasize it a little better. Alright, so in order to solve for J, I'm going to add J to both sides here. So that gives me 2J on the left side is equal to minus e to the negative theta cosine theta minus e to the minus theta sine theta. which means that this derivative is going to be half of what you see here. And so j would be minus e to negative theta over 2 parentheses cosine theta plus sine theta. So I factored out negative e to the I theta, e to the negative theta. I divided by 2, and so this integral is equal to that. All right, which means that r cosine theta is equal to negative e to the negative theta over 2 parentheses cosine theta plus sine theta. Wow, how about that? All right, plus a constant, right? Because we need a additive constant somewhere. So I forgot to put my additive constant. I'll put it there. All right, so there we go. Rather complicated problem, and I want to make sure, obviously, if it matches the book answer, otherwise I screwed up something. So let's see what we got. The book has 2r, and then they divided cosine into everything. All right, so let me see if I can get the book answer here. Bear with me. Let's erase all this junk here. Okay, so I'm going to multiply by 2 and divide by cosine. So over here, the cosine cancels. I have 2r equals to, the 2 cancels this fraction. So that's minus e to the negative theta, parentheses cosine theta plus sine theta, divided by cosine theta, plus, now if I multiply 2 times constant, I still have a constant. So I have constant over cosine theta. Well, all right, so this is 2r equals to negative e to the minus theta. If I divide cosine into this parentheses, I have a 1 plus sine over cosine is tangent, 1 plus tangent theta. And then we have plus c, and c over cosine theta would be c times the secant of theta. C secant theta. So, let's see, did we make it? 2r equals to c secant theta minus e to the negative theta times tangent theta plus 1. Ah, we have restored the universal harmony. So, feels good to get one like that, doesn't it? Alright, so there we go. We solved that differential equation. Alright, I want to do one more example with integrating factors, and then after that we'll go on to the other part here, which is the Bernoulli equation, lesson 11D. So two more videos, I think.